Welcome back to my channel. In the previous video, we discussed on what is time synchronization and why time synchronization is needed. So, in the previous video, we also discussed that the clocks in the different hardware or a computer system or the ECUs tend to drift over a period of time, and they needs to be synchronized. Now, the next question would be, what is the source with which they synchronize themselves with? What is the clock source, or what is a precise source, or what is a reliable source with which they can synchronize themselves with? So the answer is, nowadays the golden standard is the GNSS, that is a global navigation satellite system, that is the GPS, global positioning system. So these devices are called Stratum 0 devices, the GPS devices. These devices are called the Stratum 0 devices. They broadcast the time information to the servers, to the different servers, and the devices or the servers which receives the time from the stratum 0 devices are called the stratum 1 devices, and below them the other servers we have, they are called the stratum 2 this similar way we have the hierarchy till stratum 15. And yeah, this is how the time information is provided, and synchronization happens. And the synchronization can happen mainly, the most broadly or most widely used are two main protocols. They are PTP and NTP protocols. So the most common system by which for synchronizing the clock on servers or PCs or laptops or smartphones, tabs or smart TVs, etc., is the NTP, that is the network time protocol, NTP. And in the and it's one of the oldest protocol as well, and most widely used as well. In NTP, what happens is that the client will poll one or more servers here. The client will poll one or more servers and request the time, and it will once it gets the time, it will synchronize itself, synchronize its clock. And in case of NTP, the accuracy is around 10 millisecond, or it's in the range of millisecond. And coming to another protocol doing the time synchronization is PTP, precision time protocol. So this is one of the most accurate protocol. It's more accurate than the NTP, because it uses a special hardware and doesn't use any software for its calculation or for its synchronization. And here, in case of PTP, one device is determined as a grandmaster. He is the real leader, and he's the one of the most reliable source who will be sending out the time. But in case of NTP, the client will has to request the server for the time. In case of PTP, it's the grandmaster, the most reliable source, himself sending the time out. So all the clients can receive this time and synchronize themselves. And in case of PTP, the accuracy is in the range of less than 1 microsecond. So it's all usually calculated in nanoseconds. So to now to compare these two protocols, let's have a short comparison between the NTP and PTP protocol. So in general, like the PTP it has a standard called IEEE standard. It is derived in defined in 1588 with the various flavors and different profiles. And NTP is mainly used for application level synchronization, whereas the PTP is used for the precise or precision synchronization. So for example, NTP can be used in timestamping the error logs, log files, etc. But the PTP, it is as it is having a dedicated hardware to minimize the path issues and everything, so it is used for precise sync actually. And it has a high-end algorithms to eliminate the network or equipment jitter as well, so that latency. And when it comes to similarities between NTP and PTP, both are a transfer protocol that operate in band over the Ethernet networks, and both encapsulate the time in PTP or NTP packets, and both operate in master slave, that is a client server mode. And yeah, as I already mentioned, NTP has accuracy around millisecond, and PTP has accuracy around microsecond. And yeah, operation, of course, the client will request, in case of NTP, the client will request for the time from the server, and in case of PTP, the master will push the time out to the slaves. And yeah, NTP is less expensive and PTP is more expensive, as it is having a dedicated hardware on its own. So these are the comparisons. Thanks for watching the video. If you like this video, please give it a thumbs up. Thank you.